800,000. Over there.
It's about 500,000.
500,000.
In just the Philly area.
Okay, we have about, you're right, we have about 800,000 subscribers. And this is the difficult question because, you know, subscribers come, they go, it varies. Now, so we have 800,000 subscribers and we only have 416 channels. So, how do we do this? Very easy. One cell site, and let's assume I have a cell site right here. One cell site can support 57 voice channels. That's it. I can't squeeze more voices in this cell site. That's just the technological limit. The way we designed our system allows 57 voice channels per cell site in one area. If I need more people to be surfaced in this area, guess what? I need to build another cell site right beside it. Let's say I need 400 people in this area. How many cell sites do I need? 400 divided by 57 is? Yes, about 7, 8. That's what I need to do, and that's it. Because I can't, you know, can't put more voice channels in it. Let's say I have a cell site here with 57 voice channels. I built another cell site here with 57 voice channels. And then I built a third cell site, also with 57 voice channels. I can then reuse the voice channels that I have used in the first one because it's far away. There's another cell site in between, and I keep my cell radius small enough. All right, this is the heart of cellular. So again, I got 57 voice channels here. Then I use right beside it another group of 57 voice channels, you know, different set. But further down the road, because it's far away, I can reuse the ones that I used down there. And this is how we reuse frequencies all over the system. Cell sites that are on the fringes, you know, I use frequencies that I use, you know, 50 miles down the road. Doesn't work that well because every now and then, you know, you're hearing voices from other people. And I'm not saying that hearing voices is a bad thing. I'm talking about interference. Okay, that's what I'm talking. You don't want to interfere with somebody else's voice or hear somebody. And it's some of these minor problems here and there, and then we go out and down tilt antennas and do all sorts of funny things to make it work. Any questions about this? This is very important. Now, I have here a plot of part of our system. And this is, let me see here, this is the King of Prussia area. We have a few cell sites here. And as you can see, all the cell sites are sectorized. One cell site is divided in 3 sectors. You'll find that in our system, 90% of our cell sites are all sectorized. And there's all sorts of advantages related to this because I have control of energy going in different directions. So if I have problems with interference, hearing somebody else's voice somewhere, maybe I can down tilt the antenna a little bit, or maybe I can just lower the power so there's less power going in a certain area. So you want that space to play with. All right, any questions?
How do you change the towers? Is it through our switch, or do we have to go out to the actual housings to change the way the antenna angles?
Oh, if I have an actual a cell site, let's take a very basic cell site, which is some housing at the bottom, a tower, and this is an actual building, okay, with air conditioning and everything. And then there is an actual tower, and on top of the tower are the antennas. And then the antenna is connected to the cell site through a coax cable, actual thick coax cable. The antenna has a certain angle of down tilt. So what you need to do is somebody needs to climb up the tower, not us, we have other people climb for us, and then that person will down tilt the antenna. All right, so you have to actually go up and physically down tilt it. And then you will change the coverage pattern of that antenna. So the energy is going in a certain area, now you're down tilting it, and then less energy is going in one section. If you were causing interference in that. You see, that's one way of doing it. There's different ways also to fix interference problems. It all depends on what is causing the interference. Is it because of a frequency group accidentally entering that area, or is it because of a wrong frequency plan? You know, maybe I have accidentally used frequencies where I was not supposed to use them. There's some of that. You know, it's on a daily basis that we fire up cell sites. You know, it's a very intense process, and then we change frequencies all the time. And we have a total of, how many cell sites do we have?
400.
400. Come on, give me some. How much? 460? 416? Okay, how many cell sites do we have now? 416. There you go. We have 416 cell sites. You passed the class. We have a total of 406. It's a very difficult question too, because cell sites, you know, today I might fire up two, next month I might dismantle one, or I might just move one from one area to another. We do a lot of that, relocating cell sites, or even change the number of radios in the cell site, because each radio is one voice channel. I forgot to tell you that. So I might have excessive traffic in one area, so I start to plug in more radios. All right? Now, are we all clear on frequencies, sectorized antennas, omni antennas? It's a lot of information, okay? But again, I'm just going to give you the most important part. Let's look at a cellular system from just a conceptual point of view, okay? And for the sake of simplicity, how many switches do we have? How many telephone switches do we have? Another question. 4. I heard another number here. 2. 8? Okay, the number is 4. We have 4 switches. For the sake of simplicity, we're just going to look at one switch here. One switch with a few cell sites. Now, these cell sites are connected with each other. Sorry, the cell sites are connected back to the switch. If I have my switch here, the cell site is connected with the switch. You can't just have a cell site out there, you need to connect it back to the switch. So you have control over it, or you know, when people are engaged in conversations in the cell site, you want the actual speech samples to travel to the switch and route them to wherever you know, you want them to go, whoever you want to be connected with. There are 4 ways to connect a cell site with a switch. In North America, we use a lot of the first one, phone lines, plain phone lines. And when we're in building, we call it the phone line. When we're outside of the building, a combination of phone lines is then called a trunk, or T1 or DS1, all means the same thing. A second way to connect the cell site with a switch is via microwave. What is that? I might have a tower here with a dish on top of it, then another tower here with another dish, and then these 2 dishes can see each other. And then through these 2 dishes, there is high frequency energy connecting this side with this side. Why do I do this? Because maybe the terrain is too rocky. So I can't have phone lines or fiber optics in the ground. So I go microwave. Okay, they use that a lot in South America. You know, in Peru we used it a lot, in Colombia, even in Australia, where there's very rocky terrain and you just can't, or it's going to be too expensive. So what you do is just plain simple microwave dishes. A third way is via satellites, okay? And they use a lot of satellite links in the Caribbean, for instance. You know, satellite, if this is the Earth, and this is your switch, and you have a cell site here, again, there is no interconnect, so what you do, you send the signal up to a satellite, and then the satellite refracts it back to the cell site. Problem with satellite links is that they have a 0.5 second delay, which can be irritating when engaged in a conversation. The other side is they're very cheap. You know, for about $400, you can have a whole bunch of links, $400 per month. And that's why you see a lot of satellite links used in the third world countries. A fourth way to connect the switch back to a cell site is yet the ionosphere, which is like a, almost like a satellite also. Again, if this is the Earth, and this is the actual ionosphere here, this is my switch, this is my cell site, I transmit massive amounts of energy against the ionosphere and then it reflects back. Okay, like a satellite. And they use that also in a lot of countries. It's not a very reliable link because the ionosphere, the ozone layer is somewhere that there are holes in it. So sometimes you shoot the energy and it's not reflecting back, it's shooting through. Back in the Bahamas is a whole bunch of islands, and that's where they use a lot of these links, troposcatter links, to connect the cell site back to the switch. Why? We had submarine cables on the bottom of the ocean connecting the cell site back to the switch, but we had some problems with sharks destroying these links, so we ended up going troposcatter, since all satellite links were already used up. So it's these four ways that we use to connect all over the place. In our system, we only use phone lines. Okay? So, questions? So how many ways are there to connect the cells over the switch? Tell me, which are these ways?
Phone line?
Phone lines, microwave, satellite, troposcatter. There you go. Okay. Now, some more basics out of the way. If I have, where's my little cellular phone? I mean, this is an analog phone, right? Now, this is 0.6 watts of energy coming out of the transmitter of this phone using this little antenna here. That's the cell site, the top of the cell site. As you can see, big antennas. These antennas are about 3 to 5 meters long, very long, and they're about that thick. It's one thing for this big cell site, this big antenna, to transmit energy to my little phone somewhere down there. It's another thing for this little phone to transmit energy all the way up to the cell site. So this is why you'll find in an omni cell site where we use omni antennas. Remember what are omni antennas? Energy all around. You'll find us to use 2 receive antennas and 1 transmit. And why 2 receive is to help this unit. So there's 2 antennas trying to receive a signal sent by this little weak signal. They're helping it with 2, and then we switch between the 2 antennas to pick the strongest signal. All right? So that's 2 receive and 1 transmit. Same reason why we have 2 ears and 1 mouth. All right? Now, the second one, here is an example of a sectorized site. Remember sectorized when we have the cell site broken up in 3 separate sections to have all this individual control.